For the last part of section 7.1, we're going to go over some applied problems using the Pythagorean theorem. First thing I want to remind you are the two right triangles that you need to memorize the associated side lengths. The first one is a 45, 45, 90-degree triangle. And on those, the relationship between the legs and the hypotenuse, if the legs are length 1, the hypotenuse would be square root of 2. So that means if you want to go from a leg length to the hypotenuse, you multiply by the square root of 2. And if you're given the hypotenuse and you want to go to a leg length, you divide by the square root of 2. And I'll do a couple examples of that. The other triangle that you need to have memorized is a 30, 60, 90-degree triangle. The three sides that I told you to remember were the square root of 1 over 2, the square root of 2 over... so it's 1. Then we have 2, and the square root of 3. These are the three side lengths. And to go from 1 to 2, you're going to multiply by 2. So to go from the hypotenuse, from the short side to the hypotenuse, you multiply by 2. To go from the short side to the long side, you multiply by the square root of 3. Okay, my recommendation is you always work with the short side. So if I want to go from the long side to the hypotenuse, I'm going to go back through the short side by dividing by the square root of 3, and then end up multiplying it by 2. So if I wanted to do it all in one step, going from here to here, it would be times 2 over the square root of 3. Similarly, if I want to go from the hypotenuse to the long side, I always go through the short side. I do that by dividing by 2 and then multiplying by the square root of 3. So if you want to do it in one shot, you would multiply by the square root of 3 over 2. Okay. Where this comes into play is if you have a 45, 45, 90 triangle, and I tell you that that length is 4, if I want to know what the other lengths are, well, the other length's the same. The other leg is the same. So this one would just be 4. And I need to go from the leg to the hypotenuse, so I multiply it by the square root of 2. So this would be 4 root 2. Similarly, if I was given the hypotenuse of a 45, 45, 90 triangle, and I want to find the legs, I divide by the square root of 2. So that would give me 5 over root 2, but we know we have to rationalize that, and I end up with 5 root 2 over 2. Do some examples with the 30, 60, 90 triangle. If I give you the short side of a 30, 60, 90 triangle, for example, 4, to get to the hypotenuse, I am going to multiply by 2. It's going to be 8. To get to the long side, I multiply by the square root of 3, and I end up with 4 root 3. And you can use the operations in reverse instead of multiplying, dividing to get from other pieces on those triangles. So that's how you use the 30, 60, 90 and the 45, 45, 90 triangles. The other type of applied problems is finding areas of isosceles triangles. Okay, an isosceles triangle, two legs are the same length. And if I drop the angle bisector down to the third side, it splits the side in opposite halves. We covered that in a previous chapter. So we know that the area of a triangle is 1/2 base times height. Well, the base is 20. Half the base is this distance here. So I need to calculate the height. And notice I have a right triangle. So I have an 11, 10, and unknown side on a right triangle. So I calculate that. It's the square root of the hypotenuse squared minus the other leg squared. That's 121 minus 100, which is the square root of 21. So my area is 1/2 the base, which is 10, times the height, which is the square root of 21. And that would be the exact answer in units squared. I'll do another example. If I drop the angle bisector, which is perpendicular to the third side, that divides us into two pieces. That gives me a triangle with side length of 6, 10. And if you have your Pythagorean triples memorized, you automatically know that that side length is 8. But if you do not have them memorized, it's the square root of the hypotenuse squared minus the other leg squared. 100 minus 36 is 64. The square root of 64 is 8. And we know that the area of a triangle is half the base. Half the base is 6 times the height, which is 8. And in this case, I'd have 48 square units. I can also use the relationship of the Pythagorean theorem to find missing sides of other triangles. Notice that I have a big triangle that is a... See, they did not mark it as a right triangle. If it was marked as a right triangle, I could easily come up with the answer. That one's not a right triangle. But I can find this side length because it is part of a right triangle. And again, this is a Pythagorean triple. This is our 3, 4, 5 triangle. And once I know this height, I can then use the Pythagorean theorem on this side and know that that is equal to the square root of 4 squared plus 7 squared, which is 16 plus 49, which is the square root of 65. And that's 5 times 13, so that would be an exact answer right here, since 5 and 13 are both prime. So those are the examples for the second day's homework on section 7.1. So you will be doing that homework on Tuesday in class, and then Tuesday night you'll be watching the video for 7.2.